You've probably never thought about your car tires. They're round, black, hold air. All four look basically the same size. A bus has bigger versions. A bicycle has thinner ones. Even massive construction trucks. Enormous tires, yes, but still roughly equal front to back. Every vehicle quietly follows that same unspoken rule. And then you look at a tractor. The rear wheels are taller than a grown adult. Wide, aggressive, almost intimidating. And the front wheels? Narrow and small, like they belong on a different machine entirely. No other vehicle looks anything like this. Not a truck, not a crane, not a forklift, nothing. So why does this one machine break every pattern everything else follows? The answer isn't about looks. It isn't tradition, and it has almost nothing to do with carrying the tractor's weight. The real reason goes underground, literally, and once you see it, you'll understand why every proportion on that machine is exactly where it needs to be. Welcome to Simple Things Analysis, where we find the hidden logic inside things you've walked past your whole life without asking why. Let's get into it. Before you understand the wheels, you need to understand what's underneath them. Most of us look at a farm field and see dirt, brown, flat, ordinary. But under the surface is one of the most complex living systems on Earth. Healthy soil is layered with air channels, water pathways, root corridors, and billions of microorganisms doing invisible work that eventually becomes the food on your kitchen table. That underground world is shockingly fragile. When something heavy rolls across with too much concentrated force, those air pockets collapse inward. The particles lock together. The ground hardens from the inside, sometimes 60 to 90 centimeters deep, completely invisible from above. Farmers call this compaction. It's one of the most expensive and least discussed problems in modern agriculture. Compacted soil can't drain rainwater. Roots can't push through. Seeds struggle to germinate. Harvests shrink season after season. And unlike a cracked wall or broken fence, you cannot see it happening. The damage sits silently underground, quietly reducing yields for years while the farmer searches for answers in the wrong places. So every time a tractor crosses a field, it faces the same invisible challenge: get the job done without destroying the very ground that makes the job possible. That tension is exactly what shaped the wheels you're looking at. Here's where most people's instincts go completely wrong. When you see a heavy machine, you naturally assume it needs a big, tough, rigid tire. Something solid, like tires on a construction excavator or mining truck. Hard, thick, built for brutal loads. Tractor engineers think in the exact opposite direction. Their goal isn't a stronger tire, it's a larger one. Because the problem they're solving isn't how to carry the machine's weight, it's how to spread that weight across the widest possible footprint so pressure on any single patch of soil drops as low as physically possible. This is called ground pressure, measured in the same unit as air in your bicycle tires, pounds per square inch. Picture a narrow, rigid tire pushing thousands of kilograms onto a contact patch the size of a notebook page. That's a punishing amount of force hammering onto almost nothing. The soil has no choice but to collapse. Now picture a massive, wide tractor tire carrying that same load. The weight spreads across a contact patch closer to the size of a dining table. Pressure drops dramatically. The living underground structure that took years to build survives almost completely intact. The giant rear tire isn't built big because the machine is heavy. It's built big because the machine needs to be gentle. That's the counterintuitive truth sitting at the edge of every field you've ever passed. Spreading weight is only half the story. The other half is raw power, and what happens when you push it through soft, unpredictable ground. A modern large frame tractor produces between 300 and 500 horsepower at the rear axle. That's a staggering amount of rotational force pushed through two tires into loose, rain-soaked earth. Think about what a narrow tire would do under that torque after 3 days of heavy rain. One of two things. Either it spins helplessly, flinging mud sideways while the tractor goes nowhere, or it drills straight down like a drill bit, burying past the rim in seconds, leaving a massive machine stuck with a planting window closing fast. Neither option gets 40 acres planted before sunset. The large rear tire solves this through two forces working together. First, sheer surface area, hundreds of individual tread edges gripping soil simultaneously, not skimming across the top like a car tire on wet pavement, actually biting in, anchoring each rotation, converting power into forward motion instead of wasted heat and spin. Second, sidewall flex. A loaded tractor tire doesn't stay perfectly round. It flattens slightly at the bottom, spreading outward and increasing the contact patch beyond what the raw dimensions suggest. More rubber on soil, more grip, more power going forward. The whole system works like a snowshoe. A narrow boot concentrates your weight onto one point and sinks through deep snow. A wide snowshoe distributes that weight and keeps you moving on top. The massive rear tire is essentially a snowshoe for 5,000 kilograms of steel, diesel, and hydraulic machinery, engineered to float across ground that would swallow anything narrow or whole. So why are the front wheels so small? Because they're solving a completely different problem, deliberately. The rear tires handle power, grip, and soil protection. The front wheels don't transfer torque to the ground at all. The heaviest components, engine block, transmission, hydraulic systems, sit directly above the rear axle by design, placing weight exactly where grip is needed most. Engineers call it intentional weight distribution. Farmers call it traction without extra ballast. The front wheels have one job: steer with precision through crop rows planted centimeters apart, around irregular field shapes, through tight turns at the end of each pass. For that, you need something narrow, light, and responsive, built entirely for accuracy, not power. One bonus almost nobody mentions. Because the rear wheels are so tall, the driver's seat sits higher than on almost any other vehicle its size. That elevated position gives a clear line of sight over the front of the machine, critical when guiding equipment through crops within centimeters or spotting an obstacle at the far end of a long field. That dramatic size difference isn't a quirk or a cost-cutting decision. It's two completely separate engineering challenges: soil protection and grip at the rear, precision steering at the front, solved by two different tools on opposite ends of the same machine. One tractor, two jobs, every proportion exactly where it needs to be. The next time you see a tractor crawling through a muddy field, you won't just see oversized wheels. You'll see ground pressure calculations, torque transfer, soil biology protection, and decades of field testing, compressed into two rubber surfaces rolling quietly through the earth. That's what Simple Things analysis is here for. The ordinary things always go deeper than they look. If this changed how you see something you always ignored, subscribe. There's a lot more waiting for you.